Hi, good morning. My name is Sanguk. We are team number 3. We are composed of 3 members, Paolo and Dongchan. Okay, in this slide, I want to remind you to know what was our main goal. Our main goal is the feasibility study of the electric ship. We did a analyze about the 3 different sources that are able to be generate electricity, photovoltaics and wind turbine and fuel cell. And we already studied about how it works in order to know which one is the most suitable for the electric ship. And from now on, in previous presentation, we did a general study of the electric ship. From now on, we want to focus on the specific case of the electric ship. We choose 3 different energy sources that are able to produce electricity: photovoltaics, fuel cell, and wind turbine. And we choose the fuel cell is the most suitable energy source for the electric ship because it having a higher power density than the others, and also having a less noise and less energy fluctuation. For instance, the photovoltaics need a sun from the sunlight to generate electricity. So it is only possible to generate in the daytime, and also if there is no wind, the wind turbine is impossible to generate electricity. But the fuel cell is possible to generate whenever we want if there is existence of the hydrogen. But this also having a disadvantage of the cost and lifetime, so we should solve this problem. In the last presentation, we found an article which is related with the fuel cell feasibility study. So among them, we choose a ZEM-ship is means of the zero emission ship. This joint project is headed by the 9 partners and mainly led by the Ministry of the City of Hamburg in Germany. The purpose is to transfer the people from place to place, and also to comply with the emission regulation. And the partners and the Ministry of Hamburg want to know how efficient it is, and they want to know, is it really possible to operate with the power from only the fuel cell? And the specification of the ZEM-ship is looking like that. There is 2 fuel cell in each capacity of the 48 kilowatt and equipped with a hydrogen tank. It is possible to pressurize up to 300 ppb and having an energy management system. I will talk in detail later. And it's possible to load up to 100 passengers, and breadth and length looks like that. And I already talked about the fuel cell capacity, and it using a low temperature hydrogen. This fuel cell type using with the PEM fuel cell type. So we want to know why did they choose a PEM fuel cell type, and also it having a lead gel battery pack. We choose 3 representative of the fuel cell type. The most important difference is the operating temperature range. As you can see, the PEM fuel cell is operating the lowest range among them, but it leads to lowest efficiency among them. But it is possible to operate fast startup and the shutdown. The passenger ships are always in the transient condition. There will be a stop and go, and sometimes going cruising, sometimes casting off. So when they start up or when they use a fuel cell, they need a long time to warm up. So the fast startup and shutdown is the most important factor of the passenger ship. And also the second difference is what kind of fuel they are using. The PEM fuel cell type is only fed by the pure hydrogen, but the others are possible to use a carbonaceous fuel. But if you use the carbonaceous fuel, there will be definitely a harmful emission. So our goal is decrease the emission. So the PEM fuel cell type is more suitable for the passenger ship of the electric ship. And also the last difference is the power producible range. The others are possible to generate electricity very long range and the larger quantity of the power, but the PEM fuel cell having a little bit lower than the others, but this range of the power range is suitable for the passenger ship. The passenger ships are not too big to handle this power range. And this graph shows that each quantity of the shipment in each year, in each type of fuel cell, as you can see, the PEM fuel cell type is the most popular one, and also the shipment of the PEM is keep increasing. So we expect that there is a big market, so the speed of the technology development is faster than any other fuel cell type. So we think the PEM fuel cell is the most popular one. And this is the schematic of the powering system of JAMSIP. Let me introduce it briefly. The hydrogen tank is, I already said, equipped in the JAMSIP. This hydrogen tank will supply the pressurized and lower temperature of hydrogen will be supplied to the fuel cell. Then fuel cell can generate electricity and go through the energy management system. The electricity will sometimes go into the propulsion motor or sometimes go into the battery. In case of the low load condition, the energy management system can think that there is a surplus energy, then the energy will be stored in the battery. But in case of the high load, like a casting off or needs some maximum powers, then the only using with the fuel cell electricity is not enough. So from the battery also supply the electricity to the energy management system, then some of that electricity will propel the ship, and this is how it works, the SAM ship. And coming back to our schedule, we already understood how electricity is generated from 3 different sources, and also we conclude that the fuel cell is the most suitable for the electric ship, and we did a feasibility study of the electric ship, and we want to talk about several problems, and we want to suggest about some possible solution or some expectation of the problems. The SAM ship was driven with only the power of fuel cell, so we conclude that actually it is already exists, so it is possible to drive with only using with the electricity. So the fuel cell is a really high efficient type of some generator, so it having a high efficiency than the conventional internal combustion generators, and there is no emission from the tailpipe, and also it having a less noise than the conventional internal combustion, and also no dependent energy source. As I already said, the wind or some solar energy is depend on the weather condition, but the fuel cell is always possible to use whenever we want if there is enough hydrogen. And there is some several problems. To pressurize or to pump the fuel to the electric ship is really taking longer time than the fuel, the oil, and also to reform the hydrogen will take much time and much cost, and to store the low density of hydrogen we need a high pressure, and so it is it can be really dangerous situation when it is in accident, like a hydrogen tank can work as a hydrogen bomb. So we should consider where we should locate a hydrogen tank. And also the fuel pump station is not enough in Korea and even if in any other country. This is this graph shows the hydrogen is the most having a low density in any other logistic fuels. As I already said, there's 2 techniques to increase the density. The first thing is pressurize the hydrogen, or second thing is to lower the temperature. But as I already said, the hydrogen tank could work as a hydrogen bomb when it is in accident. So we should consider where should locate the hydrogen tank. Usually, up to 90% of the hydrogen is produced by the natural gas or oil. But the development of technology, we can get the hydrogen from the LZ wood or something like that. Or the most ideal case is that using with the water and sunlight energy, we can water electrolysis, then we can get a hydrogen through the water electrolysis process. So not in near future, the far future, we can get the hydrogen without any cost. And we having some choice about the no emission, because is it really having a no emission? So we checked about some life cycle analysis. There is consists of 2 processes to make a fuel definitely they will emit a emission from, as I said, the hydrogen. To make a hydrogen, they using a oil or natural gas. From that process, they will emit some emission. And also to make the battery or fuel cell tank or hydrogen tank, that kind of process also will emit a emission. So we conclude that the life cycle analysis should be conducted through some specific case. This is what kind of consideration exists now. Actually, the fuel cell system is really expensive than any other conventional system now. But in the recent trend, the fuel cell system cost is keep decreasing. We expect that this kind of the cost problem will be solved in near future, and also the fuel cell is definitely possible to reduce or cut the emission in the operating range. If there is emission from the reforming some hydrogen, something like that, but when they operating, there is definitely no emission. So some locations should cut the emission, then you should use the electric ship in the place where you want to cut the emission. And also the refueling time and efficiency is a problem in nowadays. But the invention of innovating fueling system is called ionic compression. Actually, originally the compression was done by the mechanical reciprocating piston, but the development of the ionic compression, the time also decreased, and also the efficiency was higher than the conventional one. And also, as I said, the hydrogen tank is work as like a hydrogen bomb. So we just think that how about to cover up the hydrogen tank with another plate, like a double hull. So if there is some crack of inner hydrogen tank, the leaked hydrogen is impossible to contact some flammable source. And this is our final conclusion. So we conclude that the electric ship has a big potential in future, but there is many hurdles we should solve some hurdles. So all research was that, but there was already many projects about the electric ship, but all research said about it is possible in near future, and it worked very well. So we also agree that the electric ship is feasible, but we don't know when is the exact time of the feasibility time. And we analyzed 3 different type of renewable energy sources, and we conclude that fuel cell is most suitable for the electric ship. The key factor was the energy density. In case of our ZEMSHIP study, the PEM fuel cell type was the best type of fuel cell. And perspective, the electric ship fuel cell best is in present time we have not enough the fuel pump station or some infrastructure, and also we having a technology problem, and also the fuel cell system is really expensive than any other generators. So in present time we can have some trade-off from the cost or some technology, but in near or far future it will be definitely realizable to electric ship. And we want to recommend you to use in the urban area, because if there is some emission from the life cycle, but definitely there is a low tailpipe emission, so you can use the electric ship to cut the total emission. And also there is no noise. The people will not having people will happy because there is no noise. This is end of our term project. Thank you for listening. If there is any question, just feel free to ask me.
Question from other teams?
So how do you deal with the reliability issue with your hydrogen?
You mean like a hydrogen?
Safety issue, because the
Yeah.
ship is constantly oscillating
Mm-mm.
by rain.
Mm-mm.
It might leak.
Oh yeah.
Situation. So
Yeah, we think about that problem, safety problem. So the most companies or some most government is trying to locate the most safe location, but we are thinking another some solution to cover up the double hull, like the general ship, because when there is an accident, the outer plate can be broken, but the inner side of the plate will not. I don't know. If there's a really big accident, the double hull will be definitely broke up, but in case of the some damage, then the outer plate will be prevent from the leakage. So if there is an inner plate as an inner leakage, we filled up the inert gas, so there will be no problem. Then the last sentence. But the location should be done with some simulation. But we're trying to cover up the storage tank. Yeah.
So you said that this kind of boat is feasible? Like
Yeah.
All the things are just green lights.
Yeah.
So according to you, what will be the next steps, like in the future, to like have more of those boats? Because if they're better, greener, what are the I don't know, the next checkpoints they have to?
Yeah, I think the key point is that the cost. The fuel cell system is really expensive than any other conventional generators. The cost is the most important thing, and also to operate a electric ship, there should be enough fuel pump station. Except Germany and Japan, there is no hydrogen pump station, and also the important thing is, as I said, the safety problem. Just in urban area and just silent lever can possible to operate in safety, but some harsh condition ocean, like there will be a problem of the safety. I think the cost is the most important thing.
Any other question? Okay. First of all, page number is missing.
예, 죄송합니다. 예.
Which one is which? And second one is you speak too fast.
죄송합니다.
Too fast. What you said clearly. So there's a slide about PEMFC and SOFC.
Yeah.
Something like that. So you chose PEMFC, and there's no explanation about the abbreviate term, like what's the full spelling of PEMFC, or I found FC is fuel cell.
Yeah, yeah.
We did the last time.
How do you do it last time? Okay.
There's a problem with exchange membrane fuel cell, solid oxide fuel cell, and molten carbon fuel cell.
Okay.
And the different type of electrolyte inside the fuel cell.
So does P and FC require more hydrogen tank storage?
Actually, the three types of fuel cell is all possible to use a hydrogen. But you mean the PEM fuel cell needs more hydrogen?
It's pure hydrogen, so
Yeah.
it will require more storage.
Yeah, that's right. The storage tank is really bigger than the conventional oil tank.
So you just mentioned about that, but no consideration about
The size of tank.
regarding size of ship, or what kind of what type of ship you will choose, or what type of ship will be more fit to this kind of application.
Yeah. Actually, Sebastian asked about.
Will it be really feasible for ship?
Mm-mm.
Not. I can't really say.
We did, in the last presentation, we did a general overview, and we explained why fuel cell should be have the most potential, the highest potential for the ship. We did a
I see the potential, but what I'm saying is the detail.
Mm.
Okay. And next one is, for example, you showed jamming shift.
Yeah.
How, in case of jamming shift, if once it is fully fueled,
Yeah.
how long does this shift travel?
But the report said about the.
Can it be start from the Newton port to some America or something like that?
Yeah.
It's a passenger ship which is inside the river from the city. It's like for tourism, not so.
So it's definitely passenger ship. So can this fuel cell be applied to container ship or bulk carrier?
Oh yeah. So also I want to answer about the Sebastian because he asked about the limit of the fuel cell ship. So I forgot to tell about the to travel throughout the longer distance. It needs a more pure hydrogen, right? So the tank size will be definitely larger than the about 5 times or 10 times of the conventional original tank. So oil tank. So actually, we should solve the problem of the technical issue about the pressurized hydrogen. So maybe we should, yeah. So some I already told about the ionic compression. It took less time and it having less loss. So efficiency is really good. So if the technology will be developed, then the size of tank will be decreased. I think that is a good point for the size of tank.
So what I hear overall is you start from ship and you end it with fuel cell.
Mm-mm.
Kind of anti-climax.
Mm-mm.
So if you should, I think you should have done more talk about some specific issue about space because the
Oh, yeah.
voltage you chose fuel cell is not changed. So you should have done more feasibility study
Mm-mm.
about the size of tank you have to have something like that. That's my question.
Yeah, thank you.
I noticed there has been a good progress comparing to Newton. I had this discussion. My question was to, can you click on, no, this slide. Yeah, I want to see the cost.
Yeah.
The target in 2017 is $30
Per kilowatt, yeah.
Can you compare the number, say, comparing to diesel engine?
Diesel engine.
You don't have a number. Anyway, I want to see such a comparison.
Yeah, how,
right?
yeah.
Please include.
Yeah, I will include a specific numerical value of the diesel engine cost in our report. Yeah.
There is a diagram shows energy management system.
Oh, yeah.
This one.
Uh-uh.
This one, yeah. So they ship use battery together.
Yeah, that's right.
Maybe a kind of hybrid system.
Yeah, definitely.
I guess similar to hybrid car, the energy management system is important.
Yeah.
So you need to mention a little bit more about it.
Yeah.
Right?
Yeah.
Okay.
Thank you.
Very much.
Yeah, thank you very much.
Hello, we are Team 4 and I'm Hyobi, and our topic is about the safety of seasteading. In the introduction, I want to talk about what is seasteading and some existing prototype and why safety issue is important. Seasteading is basically the idea that humans can build habitable cities on the ocean. So it's kind of like combination of cruise ships and offshores. And I want to introduce this prototype. They will be built until 2020 in French Polynesia. And in this project, they want to locate the seasteading within the territorial waters of an existing nation because of these several advantages, like they can easily engineer or fix some seasteading in relatively calm and shallow waters, and they also considered about some political or social things. So as we can see in this project, the seasteading is in really present and it will coming really soon. So our topic and the most important issue about seasteading is the safety. If there are some accidents on the land, we can evacuate from the danger source to the space around the building, but on the seasteading or offshores, it is surrounded by the ocean water, so we cannot escape from the source safely, and the best and the only way to evacuate from the offshore seasteading is just jump into the water. So we have to deal with about the safety on the ocean structures more than land things, and also the safety system is really well organized in the land because it has long history and it's developed really well. But about the seasteading, it doesn't have any case yet, so we have to more consider about the dangerous things, and also the fire or some other accidents could more spread quickly on the seasteading because the buildings on the seasteading are really close to each other, because the cost spent to make the seasteading is really high, really expensive. So we have to use the space more efficiently. So we have to build buildings more close, and it makes the fire to spread more. So next step is set the goal. As we mentioned in the second presentation, first we researched the cases from cruise ship and offshore accidents, and we analyzed those accidents from many regulations to choose our goal. So here's some statistics, and based on those statistics and list up all the causes for the accidents, we chose these 3 problems for our goal. And because I talked how we chose these problems in the second presentation, so I'm not gonna talk it again. So our main goal, the first problem is the problem from the cruise ship, and it is fire on the ship and evacuation problem, and our additional goal is the decay problems. So for the first problem, our idea was puzzle-shaped solution so that we can separate the dangerous puzzle from the rest of the puzzle. We already showed this brief drawing in the second presentation, and as I mentioned, each puzzle has their own function and they come together to form the whole seasteading. And if there is some dangerous accident occurs, then we can separate that puzzle from the rest of the rest parts of the seasteading. So here's the profit of our solution. We talked about the details of this profit in second presentation, so I'm just briefly talk about it. We can control the damage spread because we can separate the dangerous parts, and we can get the evacuation more efficiently and fastly. and we can get more safety from the load and size grow and good mobility. So based on these profits and our brief idea and drawings, we made this model. This shows the example piece of the puzzle. So for example, this puzzle has some plant structure. Maybe other puzzles have their own other functions like school puzzle or some company puzzle or something like that. As we can see in this model, its puzzle can move and exist independently and move by itself by this propeller. Actually, we need more details and more technical things to floating and move by itself, but we didn't include it because it's too technical parts, and we just want to suggest our concepts. And this video shows how our model will work. Each puzzle exists independently now, just floating on the ocean, but they can come together by move by itself, and then they will form the whole sea steading like this. And if we want, we can make some larger sea steading by just putting the puzzles additionally. And next video will show how it works in some dangerous case. For example, if there's fire on one puzzle, then it has to be separated from other puzzles where the people are living in. So the puzzle move from the other part to separate the danger. And in other case, like sometimes the parts, some central parts can have some accidents. So in that case, we can separate the puzzle by this way. Or if there's some problem on moving system of these parts, so it cannot move, then we can just separate other parts from that one puzzle. Okay. This was our first solution for the first problem. And from now on, I will talk about our additional goal about the second problem. So second problem was decaying problem. So in offshore, we started from the offshore problem. So in the offshore structures, the decay was one of the most critical problem. But it is hard to prevent decay because it always floats on the ocean. So we want to suggest some idea about this problem. Here's some existing methods. They are already used in industry. The first method is puts anti-fouling paints on the structure, and second method is attaching zinc plates, impress currents cathodic protection, and third method is marine growth prevention system. And actually we will not deal with the details of this method, but here there are some methods like this that is used for offshores already. So we can develop this method to use it to the sea steading also. Our solution for the second problem is selecting correct material for correct structure. So selecting the material appropriately is really important. And to do that, we have to understand and research the characteristics of each material, like this table. So here's some example characteristic of steel. In this graph, it shows the change of resistance to SCC, stress corrosion crack, with the change of yield strength of steel. And as you can see, when yield strength is increasing, the resistance to SCC decreases really sharply. So it is one of many important characteristics of material, and when we choose the material to use, we have to consider these characteristics. And it shows our material candidates. We chose these candidates by research because these materials are used in the industry already. So our suggestion for the additional problem is selecting the material for the structure, because in the structure every part needs different weight and design parameter. And for example, for the propeller and motor brackets, they will need more strength compared from other parts. So in those parts we have to select some material which has high strength, even though it is expensive. So our final suggestion is adding some preventing decay skills to our model. So here's the schedule that is already done, and here's some references, and thank you for listening.
Question from other team?
I have a question like on the basic principle. So your solution about fighting the fire is to basically remove one part of the steel island, but so you just let it burn like inside, like on the sea, or you just let it, okay, it's burning, so let's throw it away. And
actually, we have to deal with that fire after the separating, but we thought that the separating is the first thing that we have to do, because people are living in the rest part of the sea setting. So
don't you think that it would be easier to fight the fire if like it's easy access?
so if we can do the fire before the separate, I mean, if the fire is really small, or we can deal with, then we don't have to separate it. So maybe we have to make some criteria or algorithm when we have to separate it or when we don't have to separate it yet.
Yeah, I mean, like this is like a critical, like this is the least option, like the last thing when you cannot, like you will separate only when you cannot like extinguish the fire, right?
So of course there's some like firefighter of sea stadium or some systems, but if we cannot do that fire anymore, then we can separate, and we wanted to suggest those methods.
And I mean, like what happened after? Like the thing is on fire, and just like on the sea, on the fire, on fire and on the sea, and just derivating, following the current until it burned completely.
No, we as I mentioned, we will deal that fire after the separating.
So you separate only if it's not extinguishable.
No, you can also deal with the fire when you have to separate it. So like usually what you do in offshore firefighting is you have boats. So it's a common method to use it for offshore, also for cruise ships.
Firefighting ship.
Yeah, firefighting ships, exactly. And like for the sake of the island, it's safer when it's apart from the rest of the island, so the fire can't expand. But it makes no difference for the firefighting boats if the part of the island is close to the island or it's a few hundred meters away.
Okay, so you don't like you initially
yeah.
separate, like since it doesn't matter.
Yeah.
You whatever happens, you separate, right?
Yeah.
Okay, so it's not a critical.
No, it's not like you throw it away. It's just like you save the other party.
Okay. You say that the main difference between the fire on the sea and on the earth, that on the earth the people can escape by walking, instead here by jumping on the sea.
Yes.
But if you separate the block, the puzzle, how the people can work on it, you still have this problem. If when there is a fire, the puzzle is automatically separated, then there is some problem for the people to escape. So how do you do that?
People are living in like 100 puzzles, and if there's a fire in one puzzle, then other 99 puzzles don't have to jump into the water.
The block will be separated, I think, automatically. So
Yeah, of course, we have to first look into the content. Question? Yeah.
Again, which number are you using? Number maybe 27, but aside from the code, I can't remember. Yeah, you have number 27, but
Oh yes.
you go further, then you use the number.
Okay.
And what I remember is we borrowed this concept from another recent project.
I showed the existing.
Steady concept.
Yes.
Steady concept. So, is it from a company or a project?
The Sea Studies Institute, non-profit institute. Yeah. Can you show the slide of the institute?
So, what do they say about fire increasing violence? What do they say?
So video is coming also from institute. The video or fire or this separating.
You mean this video?
Right.
No, we
It's
made
video.
it.
Your video.
Yes.
Okay. What is their idea?
Actually, they don't really talk about fire and other accidents. The most thing they were talking about is like waves and tsunamis. It was the only safety issue they were considering. And in the moment they don't have like this floating island. Like the prototype we're building right now is more like next to an island. So it's pretty close to a shore.
So their idea is not floating, it's a fixed.
The first prototype. But for the future, they want to have this floating island, just for the building system. And they don't really talk about it. It's not really discussed. And I guess because it's so close to an island, they could evacuate immediately. They don't have these issues at the moment.
Okay. I think it looks good, but it's too simple and ideal. So it's floating on the sea and all around. So how about using that word to extinguish the fire, not just separate out all the platform from fire? I mean, separating out is a good strategy, but I mean, it looks good, but I'm not sure about is it the only place or only strategy that we could do? That's my first question. And the next one is what are remaining problems? So you solved the fire and you solved the material here.
of course, it's not perfect. As you mentioned, we can use some ocean water to solve the fire problem or something, but what we wanted to do was just suggest one idea that can solve the fire problem, and after separate the puzzle, then we can solve the fire, and then maybe we can use the puzzle again to assemble to the rest part again. And maybe actually these projects in the French Polynesia is proceeding project, so the techniques are not really perfect yet, and they don't open many information about it, many technical things. So we wanted to suggest our one model.
Okay. About fire, we have enough water around, right? In ocean environment. You only need a pump and electricity. Yeah?
Yes.
There is enough water, so it can be easier than landslide sometimes.
Okay.
That is my comment. And also, each puzzle can be assigned as their own function. There can be a hospital puzzle,
Yes.
school puzzle, and so hotel puzzle, something like that. So you can, from the beginning, you can locate some puzzle which has a high risk of fire.
Yes.
You can locate far away. So something like a power station, something like which are handling a flammable
Yes.
material. You can, from the beginning, locate them, the puzzle only, far away from the other. Right? That is another idea. Because I'm saying because the separation itself, from your video,
Yes.
separation process takes time.
Yeah. Yes.
It is a big structure, right? So it takes hours
Yeah,
or
maybe.
days, or also even, right? To separate and relocate big ones. Another one is the list of accidents.
Yes.
You mentioned that French, the existing institute are talking about a big wave as a one risk. That is my same idea. My concern is that because it is in the ocean, tsunami or typhoon can be a big problem to the city. Anyway, you need to list up all the problem cases and then pick up your own idea. Say it's okay. You can pick up fire and another one is material problem, right?
Yes.
So you choose two items, but it's okay. But you need to start from list of all the accidents or problems or risks, and then you choose two of them and say why we choose these two as the most important. There is a usual sequence of reasoning.
We mentioned about the process in second presentation.
Well, I can't remember. Anyway, you
Okay.
start from this. That is usual case. And then, and also, as TA mentioned, that you need to compare your idea with which one already exists. There is an existing project, right?
Yes.
As I see that they will start the construction next year, then probably they finished up already designing.
I think so, but
So that they have a data. So I don't know whether you can get the data. But anyway, I want to see comparison of your idea and this guy. Because you borrow ideas from them. Right?
Yes, but we cannot get many information about this project because they didn't open it. Maybe they will do these experiments and then develop it and then open all.
I understand the difficult to get collecting information, but anyway, as far as because you start from their idea, right? So you have some outline of their idea, so you can compare that so that I can see what is your better point. All right.
Okay.
Thank you very much.
Thank you. Good morning, everyone. I am Hyunji Kim from Group 1. Our group members are me, Sungwoo, Taehong, and Orvin, but Taehong and Orvin couldn't come today because they have exams right now. And I will be presenting the first half of our group's final presentation, and then Mr. Sungwoo will continue on. First, I will present our overall plan we followed throughout the semester, then how we defined our problem and our project goal. Third, the case studies we did, and then our first designs of the port. So this is the overall plan. So we have picked one small topic each week and proceeded. So we started from project planning. We did everyone, and then Orvin gave the proposal presentation, and then we did some researches and case studies, and then Taehong gave the midterm presentation last time, and then we have compared pros and cons for each design, and then came up with our final design last week. So our group thought congestion in the port were becoming a problem, and the port congestion is caused by the increase of trading via container, and then the increase of the size of the container carrier, and then the limited land area. And these causes would result in longer waiting for each cargo ships, which would lead directly into the money loss. So our group decided to overcome this problem. For the port congestions to be minimized, the capacity of the port should be increased without using any more land area. In other words, we need more efficient port in terms of container loadings and unloading time and the land area. So we set our goal to designing a port that would have higher efficiency than the existing ones. So before we came up with our ideal port design, we have done some case studies about recent ports. First case is the Venice offshore port. Venice port has decided to build an offshore port in 2013, and it is planned to be completed in 2030. And the total construction cost is estimated about 2.2 billion euros, and it is planned to handle 1.5 million TEUs annually. It is located 12.8 kilometers far from the mainland. And then the second case is the Khalifa offshore port. Out of the 5 phases, only phase 1 is constructed right now, and it has been opened in 2012. The phase 5, which is the end of the phase, will be constructed by 2030. And phase 1 took about $7.2 billion, and then the overall construction cost is estimated at $22 billion. Right now, it can handle 2 million TEUs annually, but by 2030, it will be able to handle 15 million TEUs. And it is located offshore, and it is connected by a bridge of 1 kilometer. And then we researched about the Singapore port. It was one of the busiest ports, and last year it handled about 31 million TEUs. And then we found out that it has been now it is constructing another terminal, and only phase 1 is constructing right now, which
would cost about $1.83 billion, which is a 12th terminal. And this project is planned to be completed in 2021. And Shanghai Port is the busiest port in the world. Last year, it handled about 37 million TEUs. And it has 3 major working zones, which is the Yangshan Deep Water, Huangpu River, and the Yangtze River. And then this Yangshan Deep Water is the one of the offshore ports, so we put that in. Okay, so before the midterm presentation, we have come up with the 2 designs. First one is the offshore port with the underground transfer of the containers to connect with the mainland. And then the second design was the offshore port with the boat transferring the containers with the mainland. So before choosing our final design, we have compared the pros and cons of each design and then some components. And this is the end of my part of the presentation. Mr. Soonjo will continue on right now.
Okay. We compared the offshore port and mobile harbor, but we already decided the offshore port, but we compared these 2 for reaching our final design. And the offshore port has some pros and cons, and mobile harbor has, and both of them can loading and unloading containers at both sides of the ship, and it don't use land space. So for each offshore port can be built in larger size than the mobile harbor, and we think it's more economical than mobile harbor because mobile harbor needs propulsion system and other things, and but offshore port, it could be expensive for deeper sea, and this is restricted to 500 meters. And mobile harbors can have the ability to move and cover larger range and can move into areas greater depth to accommodate big ships. But it requires fuel, so it has larger operating costs and it is hard to build large-size mobile harbor. Then there are some different ways for transporting cargoes from the offshore ports to mainland, and we thought 3 things. The first one was underground conveyor. It's literally conveyor belt for containers, and second one is bridge for trucks, and third one is boat transfer. We choose the underground conveyor because I'll show you later. And first of all, underground conveyor can offers the ships can pass freely and they operate independently of weather conditions compared to the boat transfer. And the cons will be it is hard to construct and it will be expensive. And the bridge for truck has the lower technical difficulty, but it has the limitation because it needs more ground space on the offshore terminal and may disrupt shipping or it should be built higher. And third one has higher operating cost and it has traffic and slow transport problem, and it needs a fleet for feeder ships which transfer the containers, and it has the higher risk operation. So our final design is the offshore port near the land port and the underground conveyor container transport, because when the offshore port is placed near the land port, then it can efficiently transfer the container to the mainland, and underground conveyor will minimize the offshore port space area. And then it will provide more anchorages and faster loading and unloading of containers. This is our concept design, And there are offshore ports with different sizes, and this crane can loading and unloading containers on both sides of the ship, and it can offer the increased anchorages for the ships. The side view, the cross-sectional view will be like this. That cranes can load the containers from the both sides of the ship, and there is an underground conveyors for transport the containers to the mainland, and from the mainland to the offshore port. There is offshore port, and this our concept design can give increased anchorages and offer faster container loading and unloading, and shorten the shipping time, and it is extendable without using more land spaces. This is our presentation, and thank you. Do you have any question?
Question from other team?
Why is the offshore harbor restricted to 500 meters of depth?
Because we need the supporting parts, because it need to fix on the ground, so becoming deeper is hard.
It's a fixed time, right?
Yeah, fixed. Mobile harbor can move and transfer itself, but offshore port is fixed.
Okay. Yeah. Okay. Thank you for your presentation. On page 6, is these offshore port fixed platform or floating platform?
They're all fixed platform.
Or fixed? Also, Singapore port. Yeah, this is newly built, or
It is under construction right now. Like out of several phases, only phase 1 is constructed.
Is it also offshore?
Yeah, it is built on the
On the ocean, it was built on the ocean, but this is connected to the land directly. With the trucks can move.
Okay, so page 11. So you said that offshore port is more economical.
Yes, because in this some
What reason?
the mobile harbors need many mechanical facilities, such as stability control and propulsion system, and also it uses fuels continuously. Yeah, reasons like that.
As you mentioned about mechanical facilities,
Yeah.
offshore port also requires something new types of mechanical facilities underwater, no?
Yes. That was from the
You mean
yeah
you mean the
this page.
stability?
Yeah, stability control.
Stability of
Yeah.
ship or fixed?
This ship should pick the containers and bring to here, then the stability will be problem. So we thought that.
To add to his comment, actually, for the Shanghai port, I said Yangcheng Deep Water is actually built on top of the Yangcheng Island, so it is, yeah, people don't need to really worry about the safety problem. Any more points?
Page 12. There are many disadvantages of travel and boat transfer, but just one disadvantage
Uh,
underground conveyor. So I know you have
Yeah.
to choose that one, so it should be like that, this. But
maybe
I think
you were generous.
there will be more disadvantages.
Sure. It it needs the
Can you explain just one more?
it needs the strengthen these structures, and we should when when raining a lot, the water can fill here, so we should remove the
So it allows water coming in,
yeah. You should-
transferring machine.
Yes.
So what I heard about your presentation is you just only focus about transferring,
Yes.
not about storing point of view of the offshore port. I mean,
Yes.
if I see your port,
Yes.
maybe the previous the slide that you have gave this one, you just transferring all the containers to the mainland.
Yes. Because we
It's
thought
really eventually stacked in the mainland.
yes.
The problem of the lack of space really remain to me. It's
Ah.
like that. So if the offshore
Okay.
port can also storage many containers, right?
Yes, sure. You're correct. And we thought that larger space for here will be much expensive thing, and second one, and here can be the space for containers also. So the smaller offshore port was the focus mainly. Because
Smaller offshore port.
yeah, that will be cheaper to construct than we transferring with underground conveyor. Yeah, that was the idea.
Case study is good. I can help with a good number of case studies. The problem is you mentioned that this is offshore,
Yes.
but I measure from this figure that the distance from the land to the port is
Very neat.
100 meters, only 100 meters.
Yes.
So you cannot say it's offshore. It can be a near shore.
Near shore.
Okay? Because the other case is say 80 kilometers,
Yes.
30 kilometers, only one. Khalifa is 1 kilometer.
Yes.
Then
This
I
is
can see that may not be offshore. 1 kilometer may not be offshore. But anyway, you need to
change the
change terminology. And then you can think about floating type too.
yeah
You mentioned the fixed type.
Yes.
Also you can floating type.
uh
Especially for far away,
yeah, sure.
it's better to have a floating type. Anyway, that is one idea. The final one is okay, I have two more. One more is instead of underground conveyor belt, you may choose above water elevators. Same height,
Elevators.
right? As
Yes.
deeper, it can be more cheaper. It can be cheaper than underground conveyor belt.
Yes,
So
we
above water conveyor belt can be cheaper.
right.
Same
Oh.
height, see?
We thought that the containers go upside
Right.
upper side of
Right.
the cranes.
Right.
Then we little afraid of the winds or containers.
This is
Yeah.
strong.
Yeah, we
Because
should construct
container
strong
crane
structure.
also working, right?
Yes, sure.
This same
That
height.
that will also work.
Maybe less
Work.
height than container crane. They
Yes.
are working with the wind. That's why sometimes it can be problem.
I think that will also work, and this port design is mainly focused both sides on loading and unloading. That yeah.
Good point.
Yeah.
That's why we are doing.
Yes, right. So.
Final comment is when you choose something that using a table is good, but you need to include some numbers.
Numbers, right.
It's not easy, but you only choose comparing on subjective wording. You need to have some numbers. Okay, thank you very much.
Thank you.
So, good morning, everybody. So, our project is about an underwater data center, which is following the project Natic from Microsoft. So, our team is composed by Bart, myself, and Dongjin. So, we'll go fast about the recap of the project Natic, which was already presented to you from the midterm presentation and the initial presentation. And we will go further into the cooling design and the energy supply design, and then we'll propose some the final shape and the final choice of cooling numbers and energy provider. So briefly, the project Natic is a 2016 project from Microsoft, which is where you put the data center underwater inside the shell. It's only a prototype, and since 2016 we don't have any news about this project. It's still under research. So we came from this prototype, and we made our own design of what will be the follow-up of this project. So this project is not is not energy sufficient, and not cooling. The cooling is really little because it's not that much data center inside. Only devices will measure all the electricity and power. So it's a closed system of cylindrical shape, which is supposed to stay 10 years underwater with maintenance every 5 years. And the main advantages of this system will be the fast deployment of only 90 days, where building a full warehouse of centers is take years. You obviously can use the water, what we will see after, and it can be disposed all around the coast. So you can see, this is the data center inside the shell, and this shell is cylindrical, and we will try to improve this shell to give new ideas about this project, about supply of energy and new cooling system. So our main scope were to identify the problems regarding all the underwater data about energy and cooling, and how can we overcome these problems to make this data center self-efficient underwater. So we will focus mainly on the energy supply and cooling system. So first we defined how many power needs a data center to function by itself. So we had data about existing data centers, onshore data centers, but it's the same that we will put inside the shell. And it's composed of low, medium, and high density cabinet. It's a computing term, which are each of them have an amount of power, and usually main devices are composed of 50% of low density, 35% of medium density, and 15% of high density cabinet. So the total required, if we take the average output, would be of 6.6 kilowatt per rack. So we can at least take 10 racks, this is the minimum required for making a server. we can put more racks, but this is at least 10 racks. So the minimal power for data center is 66 kilowatt. So then we focused on the energy design, and we studied in the previous presentation all the sources possible. So you had already a presentation in the course about all this energy. I will not come back to the principles, but basically you have the tidal energy, the wave energy, and the solar energy, which can be used in the water. And so we focused on 4 technologies on which we have data. Existing technologies can be implemented right away. So the wave dragon, using the wave, so the first picture, the power buoy, like here, the wave roller system, which is a new system using like the common by wave energy, and the Archimate wave swings, which is the last picture. So for each of these design, we compared the energy generation. So we wanted to make the data center self-efficient in terms of cooling and powering, and we wanted to make it so that we can put the larger amount of data center underwater, so that it can be efficient. So in the end, we chose the Archimate wave swing, which provide from 25 kilowatts to 250 kilowatts. We could have thought of other devices, but either they are too big to be deployed on a single data center, so we will need to make a data center plant, which is also possible, but you lose in terms of fast deployment because you just complexify too much the system, and we wanted to keep it like a single entity which is self-powered and can be fast deployed, because we think this is one of the main characteristics this project has, the main advantage. So we chose the Archimate wave swing, deployed in the bottom of the water. And then we focused on the cooling design. So since we don't have any previous data on underwater data center, we used previous data about the power needed to cool data center. So after a statistical study, we found out that from 33% to 50% were used for cooling in the data center energy power usage. And we found also that it must stay below 85 degrees. So we came up with a cooling design, which is we decided to keep it closed system. We could also be in an open system with the seawater, but we have a lot of problem due to pressure and leakage. And since the maintenance is supposed to happen only every 5 years, we didn't want to put an open system which is more risky in terms of maintenance. If you have algae and kind of sea life coming in tubes, and this is more risky. So at first we thought that it would be safer to keep a closed system. So we thought about a double helix inside the shell to maximize the surface and the heat exchange, and so it will use the walls of the shell to cool themselves. So that's how the heat transfer will process. And so we came up with this design. So you can see that we kept the cylindrical shape, which is maximizing the surface area for the exchange with the water. So to be inspired for this design, I just tried to implement the small surface improve you can find on motor for engine, for improving the heat transfer. And then we thought about the symbiotic design. So symbiotic is basically you have to, when you put a system underwater, you have to think about its interaction with the environment. And we came up with ideas that in some areas they're trying to implement some artificial reefs to help the sea life, or to develop new species like which has disappeared or naturally harmed by, I don't know, pollution or stuff. So they're trying to put some concrete walls underwater. So we use these walls to like design the new shape so that the small fish, can use these shapes to prevent from predators. And we also found that the fixing part of the shell could be used to put some baby reefs underwater so that they just spread out. And since the below part, like the fixed part, is only made to stay there, we can basically make it stay there for at least 10 years, or even keep it there after we just take off the data center. So we thought that it could be a great idea to just like associate the eco-friendly design to cooling improved design and like the data center project. And so this is the final design with the energy buoy. So we can see that we respected the initial idea, which was a self-efficient data center with eco-friendly design and cooling shape that increased the heat transfer. So from 250 kilowatts, we will need in computer terms, so we can put 28 racks and a total computing need of 186 kilowatts. And so if we take the 30% needed for cooling, and this is like a worst case study, because since we are underwater, we can basically have better yield than efficiency on land, but we wanted to take like no risks. So we take 33%, which represents 61 kilowatts, for a total of usage of energy, of 247 kilowatts. So this is our final design, and I hope maybe Microsoft will follow the same way. So thank you for your listening, and if you have any question, feel free to ask. Any question about the design, the eco-friendly shape? It's time.
Page 5.
Page 5?
What's the meaning of density?
Actually, it's I don't really know. It's like computing devices, but as far as I understood, it's like the amount of data you can like put into your data center. If you increase it's like pressure. Like if we can compare, it's like pressure of the data. So the high density will be like more compressed data. So you can basically put more data in like one volume. And low density would be like more, like less compressed data. I'm not really sure. It's like computing terms, and I have to admit that it's not really my field. So I just focused on the power usage, and I just found out that usually a conventional data center use 50% of low density, 35% of medium density, and 15% of high density. So I don't know what are exactly the data storage like kind of, but when you use the data center, when you send the file, maybe it's used like a part of the low density to store like the first layer of data, and maybe, I don't know. I have to admit that this is computer science. And
I think it will be much more helpful if you add some meaning of density and source of these figures.
yeah, but like I said, the main focus of this project is to
Yeah, I know,
understand
but
the shell.
You plot this number from somewhere,
Yep.
right? So what I ask is just add the source.
Yeah. The source is like coming, but I didn't display the slide because it's basically only links. So
Got it?
no use.
In page 7, you see the energy generation column, the first column,
Yeah.
the units shown are different. I mean, gigawatt hour per year and second
Yeah. This is
kilowatt hour per day.
and then it's kilowatts. Yeah. This
Yeah.
is energy and power. So
It's all different. So can you just make it all consistent?
you mean like the comparison? Only so basically, if you can I can just say that you can function for a day and put like 200 like basically you can function all day long with these systems. So the conversion with days and years can be easy. You just have to make it like function all the year to have 15 kilowatt per year. But you
So, for example, in the third wave roller,
yeah
15 kilowatt per plate.
Yeah.
Is it per day or per year? Or per
this is the power. So this is like not time dependent. But if you make it function all day, like all day long on 24 hours, it will be 15 kilowatts per day.
So
Not day, sorry. It's not per day, it's 50 kilowatts a day. Yeah, I can make it like the units conversion.
the previous project from Microsoft,
Mm.
Natix,
Yeah, Natic, Project Natic.
do they provide any solution for cooling method?
We are currently researching on it and there's no data. So that's why this is the shot we take. Like we started from the prototype, so they just gave data about the prototype and then we took out the prototype and then silence. They just probably in research state because they said that they wanted to make some energy efficient design and cooling design, but they didn't say anything about any chips or any lead. So we just thought that, yeah, okay, let's do as the Microsoft researcher and let's take from the initial prototype, let's make our assumption, our design, and who knows, maybe in 2 years we will see like a Microsoft data center with the same design as ours, maybe.
I hope so. The reason for you to go to underwater is to use natural cooling, right?
Energy, like tidal energy, and the cooling system also.
I think the main reason is for cooling, no?
Yeah, it could be so for cooling. Yeah, it's both. Yeah.
You also use some wave or energy,
Yeah.
but probably the most important reason
It's
is
cooling.
for cooling, right? But there's no such slide that can provide natural cooling, but
This is natural cooling. I mean,
Yeah,
the
I
wall
know.
shape will be surrounded by water.
And if you place this underwater, then it will be cooled down.
Yeah.
But so that's all. I mean, I think more explanation will be needed for that because all I see is you generate some energy from some type of generator, and you use some amount of energy for cooling. How about natural cooling? What about natural cooling?
Like I said, like this design is improved so that you improve the heat transfer with the water. This device, like this shell, will be surrounded by I don't know, like 10 degree or maybe 15 degree water of the sea, so that like being surrounded by a 15 constant source of cooling, it's better for efficiency of the cooling heat transfer, right? And the second part is like I tried to explain it, but we didn't want to make an open loop. Of course, you can make an open loop, like using as a cooling fluid. You could use the seawater, but it brings many drawbacks like rusting, like sea life, I don't know, risks, and leakage. The main part is leakage, and since it's like electronic devices inside, and since the maintenance is only every 5 years, which is a long period of time, at least for the first prototype, this will be a prototype, like for the first how can we say, first step of these shells. I think this is too risky to put it on an open loop, because you have too many drawbacks for not that many advantages. But yeah, of course, if we manage to face all these drawbacks and erase them, of course, using an open loop with seawater will be far better for cooling efficiency. But I think this is already an improve in cooling efficiency, since you have all the surrounding water which provide a basic cooling environment which can be used for heat transfer on this shape.
My last one is, how can this design be eco-friendly and similar to design? I think you explained it, but can you explain it again?
Like you said, like you can see, these pictures are actually artificial reefs, which were already put underwater. So these are already existing projects for helping the sea life and the fishes. So the two first one here are for helping the fish go in the hole and try to make the small fish to prevent from predators. And this one is to put basically a garden underwater, so you can put small reefs, baby reefs, and they can grow up after some time and expand on the land, so that you can repopulate a coral reef. So I tried to implement both of these systems, since we were basically using some areas, some space only for cooling. I tried to mix the two, so that I think it's better, because just putting a thing underwater, it's maybe not that efficient. But if we use symbiotic and energy and cooling, and we make try to mix everything, I think we came up with something like this. And I think this would be a great deal to think about eco-friendly. If you just think about efficiency, then you will have many data centers underwater off the shores, and maybe crushing some sea life and disturbing it. And if you don't help them in return, yeah.
Thank you. I have 3 points. One is, as TA mentioned, the cooling system. I think you should also think about the internal structure, internal rack. So inside the
This is inside
You-
double helix.
I guess you only think about air circulation inside cooling.
What do you mean?
The heat sources should be small, say CPU or something like that.
Yeah. No, it's
Electronic
racks.
devices.
It's something.
It's made of rack, right?
This is likely.
So between the container and rack, there is only air circulation, right?
Yeah.
So air circulation is not efficient for cooling. So you need to.
Yeah, but
Actually, the double helix shape is a pipeline of the water cooling, and we expect it to attach in the shell because to reduce the energy consumption in chilling from the
Right.
coolant. So that's what
Anyway,
we're expecting of.
I want to see the idea inside.
This is the idea inside.
That's too rough. Right?
What's
Too rough.
rough?
I cannot understand what is your idea. So anyway, please, I cannot understand what is it air circulation or water circulation.
It's both. Both.
Oh, I cannot see.
Like the green line is the water circulation. It is pipes of waters. It's like it is used in onshore. It's the same design that is used in onshore data centers. It's basically pipes of water circulating around the data centers, like the actual rack.
Picture of them.
I
So
don't
anyway,
have
you are
picture.
mentioning that green line curves are pipe.
Yeah.
Green.
Yeah.
Or red, what is red then?
Red is.
Red and the blue line is all the same pipe with a closed loop, and
So
it has we have double loop.
okay. Anyway, so then the red line and green line, all of them are pipe. Okay.
Yeah.
And between them is air circulate between.
Yeah.
Okay?
Yeah.
Between heat source and pipe.
Yeah,
is
but
air,
it's
right?
it's as it designed in onshore. Like the actual data centers are using this.
But I may suggest that you can increase the metal portion of heat source up to the container box, so
Yeah,
that
probably.
heat can be transferred through the metal
Yeah,
up to
probably.
the side. So another problem can be the water condensation inside because of
Yeah.
cooling and heating
Yeah.
together, right? Usually coming from your say air conditioning system, water is dripping,
Okay.
right? So you need to think about those problems. Also, anyway, I want to see more ideas of what can be done inside, because you can find better ideas.
Yeah, but like we wanted to really stick to conventional rack. Of course, we can like create some design some new racks like of this server, like you said, like with shapes, improving like metal conduction. But we really wanted to stick to some like conventional racks and mainly focus on the shell in itself. But of course, if we want to put some design for this shape racks, we could basically.
Right. Second one is, can I see the final slides? Yeah, this one. Yeah. Your counting is probably 28 racks per container, right?
Yeah.
So that number is only less than 1 megawatt. So probably that kind of small scale is, I don't see any economy to go inside the deep water. For that kind of small energy and cooling, it's easier to be done in inland.
Yeah, but there are many over advantages of putting.
My understanding is we should go into, say, big scale, big energy consumption and big cooling system. Say 100 megawatts size. Because in, say, Google or Microsoft, they have a problem with a big data center. Right? They consume 100 or 1,000 megawatts of energy and also cooling system. That kind of scale problem can be done better inside water. Otherwise, small scale is easier or simpler to use land side. So you should think about scale problem also. Right? And final small point is the comma instead of digit.
Okay.
In Korea, we usually do not use comma for point, right?
Yeah. Sorry.
So I was confused with it's a 6 megawatt.
Sorry about that.
So are you using both of them?
Yeah.
Right?
I mean,
in Europe?
in France we use comma. That like when you try to go international, we use dot. Usually, that's like this is my mistake. Sorry.
Is it okay to convert into dot?
Yeah, I can do that.
Please do.
No problem.
Okay.